I would say aloha. I'm glad to be here, and I was glad when you called me and asked me to make a presentation. And I think I'm willing to contribute to the cookbook, and I try my very best. And it's written here. Sorry for talking about physics. So it's always nice to see the waves and the surface and what the waves will cost, some money. And maybe you know a lot of the things I will try to explain, but I will try to explain how the waves work, yeah, and what are the important parameters. And so there should be a contribution to the cookbook. Okay, I have 3 topics. The first one, I have always a German word and the English word, and you can ask in whatever language you want to. Maybe there are some English words missing because I'm not doing so many presentations about wave design in English, but I try to do everything in English, and if I see some very big eyes, then maybe I use also the German words. Okay, the first point, I have some experience in whatever obstacles we will see when we try to build a wave, but I think there's so much content on the second point, layout and design. I will try to make it in 24 minutes. So I will skip the first point, but whenever you have some questions, you can ask me also about these things. And then I have 3 special projects. I have only 1 or 2 pictures on each of the projects. I want to mention. One of these is the Fritz project. Yes. Okay, we skip this. And this is Gary Schlegel. We will watch a movie with him. And it's not about the surfer, and it's not about Gary Schlegel. It's about just seeing the wave and where he surfs the wave. And my favorite picture is this one. This is why I'm doing this, why I'm so involved in trying to build more waves, to get the people together, to get the kids together, to get them outside, to make them do something together. And what's missing here in this picture is that there's always the kids, but always guys like you, like me, from the ministerium and just from the street, and women and men, and all are doing the sport together. Yeah, and it's not the main thing for me is not the surfing. The main thing is giving the sport and the spot to the people so they can meet each other and they can talk to each other. And that's missing so much in our society. That's my motivation. But also surfing is a nice sport. Okay, now let's see how Gary surfs Thalkirchen. And the important thing about Thalkirchen is that there was a wave since 1972, and this is the spot where the people say that the river surfing was invented. I don't believe it, but that's what they say. And then the wave broke down, and that's where we came in and thought about what can we do, and we just put some plastic lamellas here into the channel, and then we have, if everything is okay, we have a perfect wave. And if some parameters are not okay, we have no wave. And the second special thing is that first we did the analysis with simulation. So someone asked me today if I do wave science, and I say no, I don't do wave science. But we really did a lot of analysis work before we said this is a very simple but working installation to reinstall the wave. And so we gained some understanding of how it works and what are the main parameters. And now we can watch a simulation we did before in fact, we built the lamella system. The lamellas, we built the installation. It's just running. Okay. What changes from the perfect wave we've seen a few seconds ago to this picture? Most of us have seen it today, and some of us may have asked themselves, why did the wave break down? And then you guy went to the needles from the needle wear, and he just did a little magic thing. Maybe a few liters per second more went down the river, and then the wave stood up again. Yeah, and this is so magic, and it's only because the downstream water level changes for maybe a few millimeters, maybe 1 centimeter, and this is the difference between the perfect wave and no wave, and nothing else changes. Okay, then we see this yellow area here, and I have some ISO lines here in the symmetry plane. So what I didn't mention is, on the right side there is the wall of the channel. On the left side there's just a symmetry plane where we have a symmetric half of the wave. So I don't have so much calculation. I don't need so much calculation power. We see some boundary effects here at the wall. That's what we see in reality too. And then we see the perfect wave. And the yellow isosurface or isosurface shows us what I called in 2015 the Y impulse. So this is the vertical momentum of the flow. And in fact, it's not the vertical momentum, it's the vertical momentum flow. And this is the physical property of pressure. This is Pascal. And this is just the part of the wave which we surf. And a good wave, like we have it here, a strong wave, has a big, wide, sweet spot. So we have the yellow area will be big, and then we have a wave where we can do a lot of tricks. And when we go to, it's easy to surf, in fact, if you are used to it. And for example, in Thalkirchen, where we do not have so much water, the wave is not so strong, our sweet spot is quite small, and that is why Gary Schlegel serves a very clean line along, and everybody who knows Thalkirchen knows that you have to be very careful to be on the right spot of the wave, to have the power and to have speed and so on. So that was we don't have to watch. So now we just look at the 2D plot of this calculation. And probably it's a little hard to see. The water comes from the right. The water surface is here. Then we see here the wave. And here with the white water section, we cannot see in this plot because we have, as a legend, we have here this Y impulse, the vertical momentum flow. And we have just the surface of the water, which here's the downstream water level. Then here's the white water, which we cannot see in this plot. And then we have a nearly perfect wave, very small kicker. Yeah, okay. And what we see is this Y impulse in Pascal. And then I defined, before designing the wave, how much pressure do we need? How much vertical momentum flow do we need so that we have a wave that is good for surfing? And in this red area, we have this Y impulse or vertical momentum flow of more than 3,000 Pascal. So that's what we defined when we were thinking about how to rebuild Thalkirchen. I will get back to this. Before we get back to this, I have a parameter variation for you. This is a picture. In fact, I searched for this picture at least 1 hour yesterday evening, so I couldn't join you. I knew I have it, and I didn't know where, but I finally found it. And so this is, again, Thalkirchen. Identical geometry, identical mass flow or volumetric flow of water, and completely different waves. So this is a wave we cannot surf, or we need a very, very long board. This is the perfect wave, and this is the breaking wave. And the parameter I changed here, it's only one parameter. It's the downstream water level. And between this wave and this wave, there may be 2 centimeters or 3 centimeters of change in downstream water level. And between the perfect wave and the breaking wave, there is 1 centimeter. So it's terribly sensitive if we make a kicker-based wave, so a kicker wave, what we call it normally, then it's very important that we can adjust the downstream water level to the position of the kicker or to the position of the wave trough, I think, the bottom of the wave. What we did in Thalkirchen for the last years, what was very annoying, because we had a fixed installation because the city of Munich told us to do so, because it has to be safe, that we adjusted the downstream water level. This doesn't work anymore. It's too complicated. The cooperation with people working for the city. And therefore, we try to find a very simple installation that allows us to change the vertical position of the kicker. And so we do not adjust the downstream water level, but we adjust the bottom of the wave, in fact. And that's what most of the other, let's say, the commercial wave systems do. They adjust the position of the kicker, and so what you can do, you find the right position of the kicker, of the bottom of the wave relative to the downstream water level. And I think this is the secret of a good wave. So now a little bit of physics. How do we achieve this epsilon impulse, vertical momentum flow? So what we do is we surf downhill, like when we go skiing or snowboarding. So nothing else is done when we're staying on the wave. It's a bit more difficult because if we go too far, then we drown, and if we go on the other side, on top of the hill, then we just swim away. So, but what drives us is the gravity force of our body, and what's against this gravity force is the upward force of the flow below the board. And there we have a dynamic pressure due to the flow. And we have an area of our board. This area, in fact, is very small because we have very small boards normally. And but this is the equilibrium in the end that we have to keep. And when we calculate this dynamic force, this is what I called in those times epsilon impulse. It's just the momentum of the flow, and this is the density of water times the vertical velocity of the water times the vertical velocity of the water. This is not the kinetic energy of the water, so there's a factor of 0.5 missing. This is the momentum flow of the water, and this gives us the force that keeps our body in the equilibrium with the wave. And then we can do some estimates. What does kid need or juvenile to surf on. So we have this 1500 Pascal, which is the physical property. And if you have 50 kilogram, then you need something like 2000. And if you're a bit more heavy, like 100 kilogram, you may need vertical momentum flow of 4000 Pascal. I would say the wave we surf today has round about 7,000 or 8,000 Pascal. So this is a very powerful wave. Yeah. Like also the unit surf pool, I would say it's around about 8,000. The Eisbach in München is maybe 6,000, and Thalkirchen is 3,000, 3,500. You can surf it, but if you have 100 kilogram, it's really hard to do. If you have a mass of 30 kilogram, it's easy. It's a nice wave. Okay?
Can you compensate this by having a heavy person can
yes?
a larger board and compensate this?
Okay, I have the mass of the surfer and I have the surface of the board. Yeah. And there are some guys who have wider tails, so that works. Now, this is the physics, and I tried to conclude what parameters we need to build a good wave. The important thing is the speed of the water in the, at the bottom of the wave and the wave trough. If we have around about 5 meters per second, then it's okay. If we have 6 or 7 meters per second, it's very good. And you know that we have the velocity of the water by the power of 2. So 5 times 5 gives 25. 6 times 6 gives 36. And 7 times 7 gives 49. So if we increase the speed of the water by 2 meters per second, the force of the wave doubles. Okay? That's good. So all my last pictures, the water came from the right. Now the water comes from the left. This is a very similar plot. And we come to the numbers. The difference in the height of the upstream water level to the bottom of the wave trough, should be at least 1.25 meters. Then we have a wave that can be served, is a good wave, with enough power. There's a different parameter. I haven't got this parameter in the picture. Is the difference of the upstream water level and the downstream water level. This is decisive if you can build a wave or not. Because this is what we find in nature, or what we find in the river. And the difference here between upstream and downstream water level should be like 0.7 meters or a little more. You do not really need this 0.7 meters, but if we have 0.7 or more, then we will have a good wave. Yeah? And that's not so much. I will try to build a wave also with less than that, but this will probably not be such a powerful wave that like we have it here.
So in this case, the lower water level should be higher than the bottom of the wave.
Yeah, it is.
But here on Štvanice, I don't measure it, but I haven't measured it, but I guess we have a lower level water lower than the bottom of the wave.
I don't think so.
No.
No. Yeah, we can watch it afterwards. I'm quite sure.
When you are on the platform.
Okay, it's maybe just my illusion. But
Yeah. This is like that.
It's interesting. It's interesting.
You know, when we built the unit surf pool, they came to me and they asked me how can we do it, and we thought about it, and then in the end I said, well, we just put the wave trough below the sea level, And it's very easy. You do not need so much energy. So we pump we put the wave into the lake, and you have like 70 centimeters. You pump up the water, and then the water flows below the lake level, and you have a very powerful wave. Yeah. So we do an analysis afterwards. We take a Meier-Staude with us. Okay, so that's it. Then how much water do we need? We can talk about the flow rate. So you ask, we have 11 or 13 cubic meters per second here, and the wave's 8 meters wide. That's okay. Okay, so what I say, I don't normally don't talk about the flow rate. I talk about the specific flow rate. And if you have a specific flow rate of 1.25 meters to the power of 2 per second, then this will be a good wave. And then you just, because this is cubic meters per second per meter width of the wave. And if you have 12 cubic meters per second, okay, then you know I can build a wave that is 10 meters wide. It's very easy. And I think these are probably only this parameter, and this parameter is the one you have to know, and then you can build a wave. That's it. No questions.
But that's the minimum, huh? Better, more is better.
Yes, for sure. More is not always better. I thought we have another presentation afterwards about how to make a safe whitewater section after the wave. Will there be?
I think that's come down to Vlny that
yeah.
it's going to be,
Yeah, if you have very powerful waves, so for example, if we have like the water level difference here, 1 meter, 1.5 meters, then the wave will be so strong that for unexperienced surfers or also experienced surfers, it can be hard to get off the wave. And I saw this last week at the Eisbach. There was a rookie. I was an experienced surfer and someone who has never been there. And I watched very carefully, and he was just caught in the wave. Yeah. And the more energy, the more momentum, the bigger the difference here, the more, was ist gefährlich? Dangerous. The more dangerous this section here will become for you.
Would you say that this wave here is a really, really great example? Because if it's 7 meters, 10 or something, and it's 12 cubic meter per second, it's quite a bit more than 1.25, but it feels very safe.
Yeah, it's good. It's not too strong. It's very good. And yeah, so how much time is left?
yeah, I guess 5 to 10 roughly.
Okay, that's good. So we don't need the width of the wave. It's not so important because it's just a question how much water we have, and then we can decide how large, how wide the wave can be. And yeah, that's the same. So up to now, I've been only talking about the kicker installations. So we have a small kicker here, and the kicker just forms the wave. In fact, the kicker does only one thing. The kicker shows the water the way to go. And it shows the water, hey, you can separate from the bottom at this point. In fact, the kicker is not important if this is a good wave or not. Normally, I would say, and you can watch this also, the radius of the kicker should be very big, maybe 2 meters, maybe even 3 meters, and this forms the bottom of the wave. And how steep the wave will be is only a function of the downstream water level. Okay? So this is also one thing we can see here, what is very nice. We have a flat bottom and a smooth kicker, not steep kicker, and therefore we have such a wonderful wave. And then we just adjust how steep the wave is, how strong the wave is, by adjusting the needles. That's it. Okay? Not the kicker.
In between questions, sorry.
Yes?
It's okay to ask.
Yes?
Is it important that it has a radius? I think sometimes they're straight, no?
I don't think that you need the radius. You need the step. You have to show the water, okay, here is the point to separate. Normally we have some radius, but I said the radius can be as big as you want to, yes.
In Brandis, they have just a piece of wood there instead of a piece of
Yeah, you show the water where to separate, that's it. I think the piece of wood is not perfect, but it works. Yeah.
It's like a rounded piece of wood.
Yeah, okay, but that's it. Yeah, maybe you need some fins to shape it. Okay, and so there is another concept I like very much, and this is the floater. And for example, I always say Kunovo, but you said, how do you say it?
Brandis?
Kunovo?
Chunovo.
Chunovo. The Chunovo wave is a kicker. So the wave is formed by the installation, by the construction on the water. And there's, okay, somebody might say this is not a real wave because there's something underneath the water and so on. I say, so what? A wave is a wave, and it's a different wave. But there's two advantages. One advantage is you decouple the downstream water level variations from the shape of the wave. So what we've seen today, the downstream water level changes 0.5 centimeters, 1 centimeters, and the wave breaks down. If you have a river where the downstream water level cannot be controlled, it's very simple to install a floater. So then these two parameters are decoupled, and the wave will always be the same. And the second thing is, if you do not have a lot of water, so not these 1.25 meters square per second, then you can form a strong epsilon impulse with less water. And you can also form a wide or large sweet spot with these floater waves. And if you, for example, if you go to Chunovo and you surf there, then you feel that you have a really wide range for good surfing and not this very small sweet spot that you have to find. So I see these two differences, two advantages for floater installations. And I just wanted to mention this. And how many minutes do you give me? No, nothing. Okay.
I guess.
Okay, so then.
We have Jonathan Power from Portugal scheduled for 2 o'clock. So we have to skip the next talk, but I just told Joseph that you still.
Okay, so then for Stefan, thank you very much. If you have questions, just ask me.
Before we set up the call, I think we have like 10 minutes.
10 minutes.
So it's like
maybe you stay there.
Yeah.
How often do you see appropriate conditions for the kicker wave? Because to my understanding, the floater wave is easier to build also on conditions which are not the best. But the kicker wave, how often do you see on rivers favorable conditions? Like, could we build easily more and more waves on the rivers? Or is it rare?
Yes, I know. Okay, it's always easier to build a floater, but normally surfers like the kicker. And the critical point is, I've never seen that the critical point is technically I cannot build a wave. Normally the problem is there's some environmental issues or safety issues and things like that. If you have a place where it's water and where's a water level difference, then you will build the wave there. And
So, and then preferably it's easier to build when it's the bottom is concrete, right?
Yes, sure.
So this is another limitation. So there must be concrete bottom, right, for you being able to build the kicker, right? So
Yes, I listen to you.
and then therefore, but these they are usually in the cities, right? And so there comes these municipal limitations probably from the politicians and how did in Munich you have 3 waves and you said the second one is like it's not legal but it's not illegal. So what's the issue there? Safety?
Yes.
Responsibility.
What responsibility?
The issue is that the canal belongs to Bavaria and not the city of Munich. And the city of Munich is responsible for the first estuary. But the state of Bavaria would be responsible for the second. It's actually prohibited to swim in the whole canal. Although everybody's doing it, it's like promoted, it's like #1 activity for school children, students to jump in there and take the streetcar back to the start. But it's for legal issues.
So these are legal issues, not safety.
Yeah, they don't want to be liable. They don't want to be liable if something happens. So it's prohibited, but police won't come and fish you out.
it's insurance for the community, and the city can do it, but the region of Bavaria can't do it. And just one example yet. Now we have the famous Eisbach wave here at the Haus der Kunst at the south end of the Englische Garten. Then we have here the position of the illegal wave, yeah, with the illegal swimmers all summer long. And then we have here the Tucherpark. And so we have one channel. It's not a river, it's a channel. And we can build 1, 2, 3, 4, whatever, how many waves. So for every wave, we need maybe 200 meters of length, and then we can build the next wave, because it's only that much we need in height difference to build the next wave. And here you have the biggest possibility to build a water power plant in complete Bavaria, but they haven't done it for 20 or 30 years because of parties and lawyers and things like that. Gerichtsverfahren. Legal questions, just legal questions, yes. And this is the point. So we have 25 cubic meters water per second, 2 point something meters of water level difference, a perfect concrete channel. So easy, but, and as you know, for the city, like we say, the win-win-win-win situation, still nothing happens. At the moment, something's going on, thanks to IGSM. Yes? Yeah? No, you have to. You have always, if something's going on, you have to enjoy it.
Put up more pressure.
No, we will do it, okay? And we will, what's that? What's happened here? I wanted to talk about it because what we will do, yes. It's not so, can you see it? We have the bridge where all the people are, like here, but the people will be closer to the wave. We will have a power plant here, which will produce electricity for like 700 households and we will have the wave here, and I say we will have it, but because we will have it. And the whole thing now is integrated in the Bebauungsplan. They will make a new area for living. They build everything new, and the project owner integrated this idea in his plan. And we have this situation now at the Tucher Park, and we have it also in Dachau. So there's also an area of an old plant where they built a new designed area for living, and they just included the surfable wave in their Bebauungsplan. And maybe that's our future. So that's why I wanted to talk about these projects. And now I stop, and thank you very much, and hope that we will have a good time.